is spectrochemical series. Explain the difference between a weak field and a strong field ligand. Now, spectrochemical series is a very interesting arrangement of ligands. If the ligands are arranged in the correct order of increasing field strength, then that series is called spectrochemical series. Oh wow, what does that mean? Like say for example, I'll give you the arrangement of ligands in the order of increasing crystal field splitting power. And this is a very, you can say, toned down form of your spectrochemical series. Why I'm saying toned down? Because it has limited number of ligands only, but nonetheless it has. It begins with halide donors, iodide, bromide, chloride, fluoride, and sulfur donors, sulfur here, thiocyanate, sulfide. You can very well see that halide or sulfide donors are typically weakest field ligands. If you move ahead, oxygen donors, OH minus, oxalato, water, in all these three cases, the donor atom is oxygen atom, and you find that they are also the weak field only, they are considered weak field only. But amongst the weak ones, they are better than halide donors. You go ahead a little, now you have moderate ones, NCS minus, isothiocyanate, in which the donor atom, my dears, is not sulfur but nitrogen. This is nitrogen donor. And then you have EDTA, which is kind of mixed. Many people believe that EDTA has a giant structure, so it must be a strong field ligand. No, it is moderate to weak field only. It has 2 nitrogen and 4 oxygen donors. And then you have pure nitrogen donors, which are ammonia, ethylene, diamine. They are moderate actually, but there are people who love to call them strong field. And then cyanide and carbon monoxide are fanciful, fascinating. And yes, please don't get confused between cobalt and carbon monoxide. This is pure carbon monoxide. Carbon donors are the strongest field ligands, as you can see. So if the donation happens through carbon, they are very powerful. Through nitrogen, a bit less, but still reasonably powerful. Through oxygen, much lesser. Through halides, very poor. This, my dear, is a very good trick or a concept also, which is helpful in actually remembering spectrochemical series. Could we also compare the strong and weak field ligands? What is the meaning? What is strong field? What is weak field? Let's take a look. Strong field ligands result in greater splitting of the crystal field. That means delta O, the crystal field splitting parameter, is in fact always higher in the case of a strong field ligand as compared to a weak field ligand under similar circumstances. In fact, that is the very basis of definition of strong and weak field. If they can split the field very well, they are strong field. If they can't split properly, they are weak field. Fine. If they are strong field ligands, if the splitting between the d orbitals is very high, then the tendency to have low spin complex is high. Yes, indeed. So they tend to form low spin complexes, while weak field ligands tend to form high spin complexes wherever there is a distinction between high spin and low spin. Makes sense. What else? Sometimes people say that they are diamagnetic in nature and they are paramagnetic. It is not actually, they is not the ligands themselves. It should be the complexes. The complexes formed by them are often diamagnetic in nature. Not always. If the metal ion contains odd number of electrons, there is no power on earth or universe which can actually pair it with itself. So it would always be paramagnetic, although being a low spin complex like ferricyanide. But wherever there is a pairing possible, if there is an even number of unpaired electrons and if it is a low spin, a strong field ligand, then it tends to pair it up and you get a diamagnetic complex. And they also, it's not they, it is this only. The complexes formed by them are often paramagnetic in nature. Yes, indeed. Carbon, nitrogen and phosphorus donors. Means on the ligand itself, many different atoms may be present. Like say for example, if you have carbon monoxide, it has carbon, it also has oxygen. If oxygen is donating, it is a weak field. If carbon is donating, it is a strong field. So, carbon, nitrogen and phosphorus donors are usually strong field ligands. Halides, oxygen and sulfur donors, donor atoms. If the lone pair donor atom is oxygen, halogen or sulfur, then that becomes a weak field ligand, right? So is that a distinction? Yes, very well. And these are 4 classic distinguishing points between strong field and weak field ligands.